couple minutes. Oh, yeah.
Got like a light spot on my face. That's great.
And I'll switch to the crowd. I'll switch to the crowd view so it's just not your face when someone pops in.
Yeah, that's cool. Do I have like a giant head on the screen up there? I always thought that's weird.
Did somebody new just get hired in it? A friend of mine just got hired at a trading company in Chicago. Anybody come up? A big company. Like, right. It's like 7:10. Yeah. You know what? Yeah. She's like, asking, totally. Yeah. First time I was like, that's violating the sanctity of these meetings. But, yes. Probably. So I guess we'll get started. It's 10 minutes have gone by now. So yeah, thanks everybody for coming. Tonight, Adam Baldwin is going to talk about node security, and pretty much his only qualification to talk about it is the fact that he does it. He's not very good at it or very knowledgeable, but he's one of the people that actually is willing to do it. And he's part of, or the runner of, the Node Security Project. He knows a lot about the different vulnerabilities and common NPM modules and different versions of Node, sort of how you can monitor them and that I guess infecting, whatever your Node deployment happens. And with that terrible lead-in, I'm going to turn it over to Adam.
Turn it over. All right. Can everybody hear me?
Yep.
Confirmation. All right. And let's see. Let's make sure that we can share some slides here. And you can see that wonderful monkey business. So as soon as I press play on this, on my presentation, I will no longer see all of you, but hopefully you'll have the mic on if you want to interject something. Since we're doing this live, we might as well just ask questions live. So if you do want to interrupt me, go ahead. We'll try to, answer a question or, get things addressed in the middle. Otherwise, you can wait till the end and we'll do some Q&A at the end. So let's see. Let's find a slide deck. And can somebody confirm they can see that?
Yep.
Cool. All right. Well, thanks everyone. This is Node Security. I'm Adam Baldwin. I am definitely not that Adam Baldwin. I'm this Adam Baldwin. This is where you can find me on the internet. Adam_Baldwin on Twitter or Evil Packet on GitHub. I work for a wonderful company called And Yet, where I run the Lyft security team, as well as I run the Node Security Project. And today we're going to talk about, basically today I've put together some content from various sources that I've talked about before, and some things that I've basically wanted to talk about and that I enjoy talking about, with the hopes that that you'll gain some new perspective when it comes to security. This talk may not be that technical, so if you're looking for technical in-depth, we probably have to hash that out in the Q&A. Most of my talks, you all are smart people. You can gain technical knowledge fairly easily on your own. What I bring to the table is a perspective from the attacker's point of view, from the security mindset, and that's what I've been doing within the Node community for the last 4 years is applying that perspective, trying to find vulnerabilities and figure out how to make things better. And I also hope to impart some curiosity on your part when it comes to where the dev world and the security world, or the ops world and the security worlds intersect, right? Whatever your flavor may be. So to start off, I'm going to tell you a story about how I got into Node security. And it was probably 4 years ago. I sent an email to Isaac Schluter that all of the SHA hashes for every user within NPM was exposed, right? Now today we call that a breach, right? We but back then, specifically for Couch, which the registry ran on and runs on, Couch had exposed those hashes, and that was just the way that it came by default. And so that was also sort of the registry's foray into kind of its first one of the first security incidents and having to deal with that. If you can crack that SHA on the screen, you can figure out whose password that was. And it was somebody very infamous in the Node community, but I won't tell you who. I'll just leave that a little while longer, and I'll give you the slides afterwards if you want to have fun. So we're going to talk about three things. We're going to talk about your code. We're going to talk about third-party code, and specifically we're going to talk, and then first we're going to talk Node Core. Because I think those are the sort of three interesting areas within Node. So let's break down Node Core a little bit. Node Core, most of you, again, this is a Node, Node Bitburg. It's probably the fact that it's Node. You all know about Node Core. You all know the details and the inner workings. But I thought I'd go through it a little bit anyway. And the fact that you know, Node Core, you know, it's built on V8, right? It's you know, has this I/O layer between it and the operating system, and then it's got all this interesting modules that it also includes, right? Net module, HTTP, and this is the interesting surface area to me with Node Core from a security perspective, right? You don't have a lot of control over Node Core. You have to trust all of the Node Foundation to do its best job to keep vulnerabilities out of Node Core or to respond to them, as well as you have to you know, trust that there's no malicious operators within that as well, and all the contributors, right? They make up and they secure this, you know, this, I'm gesturing, but you can't see me, which is silly, is they make up, you know, all the patches and things for these modules. So I'm going to talk about something that's interesting to me that's part of a story of the Node Core security over this last year. This is, the logo is there for my own amusement because it's very similar to the Heartbleed vulnerability that came out. For us and Macintosh recognized that there was an interesting API problem with Node Core, and that it was something that a lot of developers didn't realize, is that buffers would return uninitialized memory if not zeroed out. And it's very similar to Heartbleed, but different. And so basically, if you had, say, you know, we all, you know, if you know the new buffer syntax, you need a new buffer X, and you provided an integer, it's going to give you a buffer of that size. Well, one common thing within Node frameworks and Node applications is take a base 64 string, say when you're passing along data in a WebSocket or something, and then passing it into a function like this, where it's new buffer X. Well, if that X happens to be an integer, and you return that back to the user, you return them back uninitialized memory. And it was an interesting problem because it's sort of the fault of, you know, JavaScript not being super type safe. It's just a quirk of that API, and you know, API that's been around for quite a while. And you know, something that the I don't think most developers understand about Core is that there was a real discussion, a real you know, arguments and back and forth with regard to how to address this, right? Because you had the zero fill option, you could fill your buffers. But the thing about it is that JavaScript developers came, you know, and like JavaScript because they don't have to handle that crap, and they have to, you know, they don't have to handle this memory management minutia that you get with, you know, C and assembler and whatever. They want that taken care of, and so it was behavior that not a lot of people knew about. So Core worked through this particular issue, and what we got out of it was a couple of options. We got some new APIs, right? So within Core, we had some new APIs that help you handle buffers better, and it would be a great deal if you're dealing with buffers in your code to go check out this documentation and go work your way towards these new buffers that are a more safe implementation. And for legacy, we also have, if you want to make very sure that your buffers are zeroed out for a performance hit, you have this node zero fill buffers option as well. And make sure you put the option before your index, otherwise it won't actually work. Your app will still run, but it just won't zero fill them. I freaked out when I was testing that because I switched those around, index and zero fill, and it was still working. And I was like, was there a regression? You know, what happened? And so that's kind of an interesting thing about Node Core is that, you know, that we don't have a lot of control there, and we also don't have the same problem. So we have an interesting thing where we're bringing in a lot of V8 vulnerabilities, OpenSSL as those are found, and then we've also got a lot of other, you know, the pain points that have been mostly HTTP is where the vulnerabilities have been identified in the parser there. What's interesting is that vulnerabilities in Core often don't necessarily mean an exploitable situation for your application necessarily. You have to have the right pattern for that particular API, just like this buffer one, just like some of the HTTP ones. But it's a good idea to keep sort of your Node Core up to date, as well as keep an eye on for security vulnerabilities. And here are those resources. Here are the places that you're going to want to keep yourself attuned to, so that you, or if you find a security vulnerability or think you've found something, you can report it to security@nodejs.org. That's pretty much the situation with core. I think now the foundation is taken over core. We've really seen this security story improve with regard to communication and new releases such as for OpenSSL and things that have stagnated in the past. I think that's drastically improved. So on to the next section, right? Your code. We've got a little boat there. I like that little boat. Your code is the place where you're going to interject bugs, right? As developers, we are bug creating machines. They launch from our fingertips into our terminal, and that's where they live. But what's nice about the code that we write and the bugs that we create is that you have the most control of the code that you actually write versus say Node Core. You control the data input, you control where that data flows to, and how it flows throughout your application. You have great control over that. And one thing that I think is important about your code is also nothing is ever secure as the code that you never wrote, the surface area that you never created. There's a tweet that I tried to find. It's really great. It says, it talks about a junior developer. Is so excited about the number of additions in code, right? Wrote this feature, and the regular sort of mid-level developer is excited about the code that they deleted, right? Like that they got excited about the code they deleted, and the senior developer, which of course is junior, mid, senior, just BS, but senior is just is excited about the code that they never wrote, right? The code that they prevented getting written, and I think that's very valid when it comes from a security perspective. Is that if you don't add that API feature, if you don't add that extra option or that weird clever call that you don't need in there, by doing just a little bit more design or a little bit more thinking about the problem, you eliminate surface area and therefore enhance security. Let's see, I had a thought, but I ran off. Okay. And so let's see, your code. One of the things that I want to talk about with your code is my methodology for finding flaws. So when I look at an application, it's taken me many years to distill this down into this basically one slide of how I approach finding vulnerabilities within an application. And really, it's understanding the most you can about the technology being used, right? How do we understand the threat model of Node? How do we understand what data comes in and out of our application, right? What are we using? HTTP? Are we using DNS? Are we using just TCP? What technologies are we using? Then understanding those common weaknesses, right? Understanding what are the possible attacks against those technologies, right? If you're using FS as an example, directory traversal or is a thing, right? Being able to put in, say, an absolute path or a .. / up to a relative path up to another file location, right? And then from there, it's really about finding inputs to your application. Where can the users provide input? Where is that data? How is that data flowing throughout your application? And then where is it headed to? Is it coming from a web browser and ending up in a SQL database? Is it coming from a web browser going into a controller and then going back out to a web browser and being rendered, where you'd have something like cross-site scripting, or the first you'd have SQL injection, or a NoSQL database, right? Where you have a different type of injection possibility. And then you have to have curiosity and persistence. And I want to show you one interesting thing where, one example where I've gone over and found a vulnerability in a module as we were auditing modules. And this is a regular expression denial of service vulnerability. And regular expression denial of service is when you take user input and you pass it into a regular expression, and you get a catastrophic backtracing situation. And because Node Core has this wonderful thing called the event loop, and we only have one of them. If you ever block it, blocking's bad, right? So if you don't fully understand the event loop, I suggest my coworkers talk "What the heck is event loop anyway?" by Philip Roberts. go there, look at that. You'll understand more about the event loop than you did before. And so what this example that I'm going to show you is the MS module. It's a probably 100-line module, and it has this regular expression in it. And when you pass user input into it, particularly 55555 space minute A, it will block the event loop. And I wanted to show that here. Let's see if I can. Of course, this is going to break. Should be able to see a screen. Hopefully that's big enough. Somebody give me any indication if that's big enough or not.
Yep, looks good.
Cool. Okay, so let's see. So MS. The node MS module is very simple, right? npm ignore, license, readme, index. It's all in the index file. There's no dependencies, no nothing. It's one of the top 100 modules. And it doesn't do a whole lot, right? It takes take the value and some options, and based on those value and options, it calls parse. And parse really just does some magic, but ultimately, right, you see this particular match right here. We're doing a match right off the bat. So if our user input ends up in that string, you will end up with a block, right? And I'll show you what that looks like in terminal here. Here's our particular case, right? Here's a really crappy function to generate a string. And if we pass in, say, an integer, it'll generate, a bunch of fives, space, and then this. So what happens is it's basically creates a giant tree of potential paths for success. And then because it actually has a failure here at the end, it's trying to find the best way to match it. If it has to check every single one of those possibilities to see if it's got a potential match. So if we do a time on this, I can't type, 1,000, right? We get, just a few seconds. If we do 10,000, it's like, or it's a, what, 0.8 seconds. If we do 40,000, right, it's blocking more. See if that actually finishes. Should block for 11 seconds. So you see that if you happen to be using this server side, you have a potential blocking catastrophic situation, denial of service situation. The fix was really simple that Guillermo did, and that fix was to just limit the input. So in let's see, still have it here. Policy, yeah, okay. And have a string over 10,000 characters. So you still get a minor block, but that's all he did to fix that particular issue. They could actually fix the regular expression, but instead took that route. So you still get a minor DOS, but it's fairly limited. Oops, it's not in there. Anyway, so that's that. Let me play this again. So in just thinking about your code, again, your responsibility there is to understand the technologies being in use, understand what those potential flaws are against those. And there's a really good resource that's often cited as the OWASP Top 10. Is a great place to start, especially if you're building web applications. Is a great resource to let's see if I got it up here. It's got a list of basically all of the common flaws, right? The injection flaws, the authentication flaws, cross-site scripting. And the thing to remember is that these are generic, right? They're not specific to Node, because we really stand on the shoulder of giants here in terms of all these flaws that you're going to find in your Node applications, your Node apps. You're going to be finding those in other apps, Perl apps, PHP apps, and so we can really learn from those other environments on those other languages, those other frameworks on flaws. So don't limit yourself. If you're looking into this stuff, don't limit it to Node specific type research. So let's see. Those are a couple interesting spots. The most interesting to me, and probably the most meat of this whole talk, is about third-party code. When I got into into Node, 4 years back, probably 4+ years, we were building a product. Andy was building a product in Node, and we were also consulting with customers. And so I was trying to figure out where are the flaws going to be with the applications, right? We have control of the code we write. We can peer review that. We can do a good job of policing that. We have to trust Node Core a bit. And then we've got this culture of tiny modules, right? Back when I started, there was probably 10, 12,000 modules in the registry. And looking at the surface area, the apps we were building, it was probably a percent, maybe less of code that we were writing was actually our code. And we were instead bringing in all this code from all these other people. Like 99% of the code that our app was running was literally other people's code. And so that's what got me interested in researching NPM and researching sort of the threat model there. And that'll be the rest of the talk here. So when you look at our package JSON, this is what we get, right? We got the dependencies that we require, and those are the ones that we have right in our package JSON, right? But there's this giant sort of nesting that happens because obviously dependencies can have dependencies and all the way down, right? And this is what it looks like, and so it's important to understand that is the case, and to be aware of what you're bringing into your application. So that's what we're going to talk about. Specifically, we talk about scripts, authors, and dependencies, the most sort of risk-inducing areas of a particular module. Of course, we wouldn't have this wonderful module ecosystem without NPM, right? All of these modules are hosted on NPM, and so one interesting way is to actually compromise NPM, right? So we'll talk a little bit about the NPM now. And every so often, it's sort of discovered that malicious code can be hosted on NPM, right? That we can put up the RIM refall module and post it to Hacker News and try to get people to RMRF their drives, which somebody did. And this is all it's discovered time and time again, right? It's been this way for years and years. And we have an option. We have this option -- ignore scripts. You can run ignore scripts if you want to just pull down a module, without running the scripts and then take a look at it, right? Or you can pull down the tarball and take a look at it, right? Which would probably be more safe. But this is because of install scripts, right? And you can find out more about install scripts, but there's basically these hooks as the life cycle of a package installs and uninstalls, or builds. There's these install scripts that let packages do fun things when they get installed, right? So if you install npmi totally not a virus, trust me, I'm a dolphin, it just puts a picture of itself up on your terminal, but it's an example of that it could do other malicious things if it wanted to. And that's where this sort of story about a worm, this big blow up earlier this year, got started, that we could have a worm situation within NPM, because my totally not a virus, trust me, I'm a dolphin module could take your .npmrc file, which you've authenticated if you're module author to NPM, and it could grab that token then and then try to pull down and publish to the modules that you have access to, thus creating a worm-like situation. Whoever depends on those modules, and so forth and so forth. But we have an interesting problem, because I have to get you to install totally not a virus, trust me, I'm a dolphin first. And now there are some stubborn people out there that will just install this module. But the reality is that you're going to be like, yeah, no, dude, I'm not installing that module. Or you might go look at it first. And to start off that, plus you have to maybe be some type of prolific author to have a number of packages out there, and have to have that worm-like effect, right? And so it got me thinking, because this isn't new to us. This is a conversation we had years ago about this particular phenomenon. And so I was like, okay, what's interesting? How do we get you as a developer, as a module author, to install modules? Well, it turns out that humans make mistakes. right? Humans are bad at typing, and sometimes we just type the wrong thing. And so what I did was I did an analysis of the HTTP logs of the NPM registry. At the time, Isaac provided those to me. And I looked at the typos. I generated typos for the top 1,000 modules at the time. And then I looked for 404s in the logs to see who tried to install that version of that typo. And turns out that there is a really, really good vector here, and that punctuation causes confusion. Punctuation causes us, because we don't know if it's socket.io or socket.io or CoffeeScript or coffee-script. I published CoffeeScript, which is not the real module, probably a couple years ago, and it did nothing. And it lasted about a week in the registry and about 200 downloads before it got captured. But still, then, like, was it enough to create a wormhole situation? I don't know. So that's an interesting, interesting stat. This is what I have from there. What else stops me from publishing modules, right? As you, well, passwords. And passwords, I blurred this out on purpose because I didn't want to embarrass the person that did it. We did a scan across the registry of people who use usernames as passwords. And turns out that a number of people did, and some of those people had packages that had were dependent on, all the way up into some very popular packages. And so even though your little simple module, might not be that important to you, if it starts getting used by something else, you all of a sudden have this, responsibility to have good security practices, right? And that sort of brings us to the people of this problem. And I mean, when was the last time you changed your NPM password, right? I can't see a show of hands because I can't see you. But chances are it's not been that recent because NPM conveniently sticks it in a configuration file for you, right? So you have to have some diligence on your part into changing your NPM password. I'd highly suggest that everyone do that on a regular basis. They don't enforce it yet, but it's a good practice. So the people of this is that we've got a couple of different actors, right? We're assuming up to this point, sort of, we've got malicious actors where they could be trying to compromise NPM and actually modify those modules, and we've got non-malicious actors that make mistakes and that the malicious actors can take advantage of. Just to kind of talk about the people of NPM, one person of the can influence the 20 of the top 100 modules. That person happens to be the CEO of NPM, so it's probably in their best interest to not do anything there. But it just shows that small modules can also have that these modules can have wide-ranging impacts. One person can have was what I meant. One person can have a lot of impact across the ecosystem. If you look at things like Express has 4 people that can be a core contributor. But when you install Express, you install a bunch of other crap as well, right? It's something more like 40 people are actually shipping code just for Express, right? When you look at Happy, it's just Aaron Hammer. Hey, Aaron, this is probably outdated, and there's probably more people than that. But you get sort of this social graph that do all of these people have good good ethics? Probably. Do all of them have good security practices? Maybe. Do all of them have uncompromised laptops? Maybe. You see that the thing is that as an organization or as a user of these modules, you inherit the behaviors of the users that are behind these popular modules or not so popular modules. This is one as an example I found. I don't remember what module it is now, but this is one module in the registry that has the most people behind it. It's not a very popular module, but it's just sort of for demonstration purposes that this can, that sort of like the number of people shipping code into your production app can become ridiculous, right? And Then we got this last sort of thing that came up this year as well, and that's sort of the change in control. You know, what happens? So the background here is that a module got unpublished. The module was a fairly popular module, along with like a couple hundred other modules. And what's interesting is that it is in this situation, it was a land grab. So just like your domain expiring, you know, if Microsoft.com expires and you snipe it up, well, guess what? You're now Microsoft.com. The same situation was true about these modules. And so, you know, while some people built tools to sort of detect if you're dependent upon those, what our team was doing was monitoring those to see if they were being used for malicious purposes. So as they were being re-registered by people that were like, ah, crap, we're dependent on this, we'll just republish the, you know, the last release up there, just so it works for people. You know, we were monitoring for you know, sort of malicious things in nature. And so now the new rules are if you unpublish, if it's less than 24 hours old, you can unpublish it, and it will be completely removed from the registry. And if it's older than that, it will fail, and you have to actually contact support. And it's at their discretion that they will either unpublish it or, you know, do something else. Now they have a policy and a process that they should follow, you know, for that, and that's the best way to do that. Let's see. So that's where, you know, so we leave it there. Let's say we do have a malicious module in the registry. Kind of bouncing around here. I was going to show you a really interesting demo, but my demo seg faults. I fired it up, and a particular dependency seg faults, and I can't get it to work on any machine or VM that I have. So I'm not going to show you. Basically, we've got the ability now to instrument, you know, with tooling, instrument Docker containers to look at what modules do on install. So we can look and see, did it access npm-rc? Did it talk to a server other than npm? And maybe that's an interesting flag. And so we're trying to work out a system or a way to sort of get an early detection for modules that may be, you know, RMRFing everything, or that may be, you know, trying to open a reverse shell up to a remote server or something. As well as I tried an experiment. This is an old slide. You know, Docker diff is a great tool as well if you ever want to know what something's doing after install. It'll tell you anything that's added, modified, or deleted. And this is an example from the rimmerfault module. You can see that it deleted 137 files when we had it run, just by using just running it in Docker container and then doing Docker diff on it. Nothing special there, but it showed that it was, you know, malicious. So that's interesting, maybe from a security team perspective, somebody that's doing the auditing of those. So, you know, that was a lot of like sort of historical, you know, security issues with the registry, you know, and sort of problems. You know, NPM, you know, the thing that I don't think gets talked about enough is that NPM does quite a bit to sort of have our back when it comes to that ecosystem, right? Just like Core does a lot with, you know, their discussions and their, you know, arguments, and, you know, making sure that the APIs are great for us going forward, and that they try to have our best interests at heart and do so in an open way. NPM doesn't talk about the things that they do with the registry. You know, for the last 4 years, I've been working with, you know, Isaac and the registry, you know, pointing out vulnerabilities and making that better. And, you know, more recently, they've turned NPM into, you know, NPM Inc. And they've gotten funding to, you know, make the registry more stable. And a lot of people complain that the registry is, you know, slow or whatever. But the fact is that it's not down for 16-hour periods of time. And then it does serve up a lot of content and does so very quickly for us. They're handling a massive amount of load and donating most of that to the open source ecosystem and open source. We do, so every piece of code, just so to understand a little bit more about what NPM does for the ecosystem, NPM Inc. pays to have every pull request that ships to an NPM product, internally or externally, that goes through our team. So we do a code review of that before, you know, to identify flaws, as well as, you know, penetration testing and, you know, just general guidance. They have, you know, a security process in place to sort of field those questions, and they're working to add features, right? They're working to add two-factor auth, and they're, every time these things get brought up, somebody in the room, sort of shouts, code signing. Well, that's good, and that solves some of the threat, but it doesn't solve everything, right? It doesn't solve the typo condition, and so they know about these things, and they're juggling the the need to keep things going forward so that we continue to have the registry, plus make things secure, performant, usable, all those things. So I wanted to sort of get a soapbox and mention that as well, because I don't think that gets talked about enough. And finally, I'm gonna talk about some of the stuff we're doing at the Node Security Project that you can do for your apps to kind of keep on top of them from a known security vulnerability, right? So I talked about your code and sort of the methodology that I use to that you can use to find problems in your own code. But what are some of the resources that you have from the Node Security Project? I think the first here, is the advisories. Just some of those. You're gonna go look through those. That's a great place to start too, to just familiarize yourself with some of the different flaws that we found and different vulnerability classes if you're not, technically savvy with some of those vulnerabilities. There's a lot of XSS, cross-site scripting vulnerabilities here, because we had an intern this summer churning through a list of 24,000 GitHub issues that were flagged with having potential security impact, that were potential vulnerabilities that were reported to. They're reported and basically, could have vulnerabilities. So we're now just sort of going through those and validating, vetting those, and getting those to the authors. So you'll see a lot more of those coming through. And she was basically focused quite heavily on SQL injection and cross-site scripting. And if you're not familiar with it, you can use NSP, so you can npmi NSP and just do NSP check. It will actually test your application for sort of known flaws, right? And so this is great to sort of add to the build process, right? Here's our demo app, simple. It's got a couple of dependencies in there, and if we run NSP check, it'll sort of just dump those out and give us a link to more information, and tell us here's the vulnerable versions, here's what's patched, and so you can update that. And that's great for, you want a one-time check, things like that. But we've been working on making that platform a little bit better. So I'm going to talk about this now, is our NSP Live, which is, sort of our effort to, on the one aspect, to fund the project, right? To keep those vulnerabilities flowing. It's free for open source. And so you can just go hook up your GitHub repos and have them checked. And so what happens is we run that same NSP check process behind the scenes whenever you submit a pull request. Let's see, let's get into one of our projects, private demo here. And so every time that you submit, this is probably got some history. Every time you submit a pull request, right, it's going to tell you that you've got these vulnerabilities. And if we do, let's see, if we've got one, we have nightly. So the other thing too is that with NSP check, the command line, if you just go wedge that into a Javascript or Circle CI or something, and you're reliant on that being checked when code is pushed. Sometimes advisories come out, but you'll have a stale repository, right? So we also check nightly or daily, right? We just check to make sure that no new advisories have crept in that haven't been introduced into your project. You also can add exceptions, sort of just new. This is great. This is a cool bug. So you can add exceptions for vulnerabilities that let's say. Uglify.js. There's a vulnerability in Uglify.js that's probably not exploitable for your app, and it's probably going to bug you and break your builds. And so you can add an exception for that right in the UI. In fact, let's see. I can probably push to this. Sure. If this actually works. and passwords. Okay, so it's there. I don't know what I'm doing. This is where you watch the security guy try to code, and fails horribly. But this is something that our team is pretty darn proud of. Let's just do happy 10. Well, yeah, that's not GitHub. Private. All right, cool. Share pull requests. Let's hope this works. These live demos that are unplanned rarely work.
As a side comment, if I try Googling for NSP Live right now, I get Ninja Party Live. You might want to consider a different name.
Yeah, we've had the name for quite a while. We might reconsider the live part. Yes, that's a good point. So this is cool. This is where okay. So it finally finished. Basically, it said it found 4 vulnerabilities. Right. We've got details. Details are going to bring us into the app where you're going to see. The different, you can go look at sort of the different, here's details about this vulnerability. But the one thing that we've really worked hard on is the sort of how to fix, right? It's going to tell you the exact minimum version you need to go to, no matter where that is in the tree. So if it's like really nested down, it'll tell you what top level dependency to bump to fix that vuln, right? So it'll tell you, this is for happy, but it would tell you, if it was some sub dependency, it would tell you bump happy to this version. And so you can either just mash the button to fix it, or we can select all of them and then we can hit fix selected. And so it's going to retry it, but it's also going to push a commit onto there and rerun that. So hopefully your tests are going to run, your security checks are going to run, and that's one of our, one of the newest features we pushed on there. So we're pretty proud of that. And other than that, let's see. Yeah, if you ever find a vulnerability, particularly if you're a module author, please, self-disclose. Let us know. This gets us into the hands of the community and lets them know that there's a vulnerability and that they need to update. You can also add deprecation warnings to your old versions. Yeah, there's a guy standing on a Lego, sort of standing on the shoulder of giants. And that's really all the security babble that I have for you today. And I hope that there's some questions and I can answer sort of anything. But I can, yeah. Thanks.
Sure, yeah. So what do you do about there's a lot of starter packs or pre-built setups that you don't really have control over the versions of things that they use. So when you get a scan of your project, let's say you built something that wraps Express or whatever, is your only course to bother the original author there?
Well, so that's not the only course. I mean, you could patch it in your node modules and check in your node modules directory. Okay. And there's tools to do that. I don't particularly agree with that approach because I don't know the behavior that patch is inducing, right, or introducing. We tend to try to get module authors to fix the vulnerabilities, but you're right, there's a problem of the dependence of that module getting things fixed. We're trying to figure out a good way of doing notifications or some type of, hey, you need a version bump, but we don't want to be annoying if we just go make some bot that just trolls around to get our repos and throws in a pull request or throws in an issue. That tends to get people pissed off. So we've been trying to figure out a way of opt-in or some some way of doing that notification. Your best bet is to, though, get them to version bump that, right? Get them to get that new version in there. It's annoying too because sometimes those subdependencies or those, you can add exceptions as well, right? Because sometimes those subdependencies just don't create a vulnerable situation for you because you may not be using that module in that certain way. So it's kind of an annoying problem right now. The Gulp authors and maintainers are kind of dealing with that right now, where there's they get triggered on sort of this false positive, where it's not really vulnerable. They don't have a vulnerable situation, but because it could be in some situations, that advisory triggers, and so it's kind of annoying, right? We're trying to solve that. If anyone has any good ideas, please throw them our general direction.
Adam, what are your impressions of the Node.crypto library and its dependencies on SSL and OpenSSL? And
not a crypto expert, so I'm not a lawyer. I think most of that relies on OpenSSL. I think that they've done a good choice in selecting the good cipher suites and things like that to use as default. But nothing's perfect, and I think you'll see some things in this space coming soon. But and that's all I can say about that. But so while I can say that I think I don't know. I don't know much. I'm not a crypto expert, but I do know that they've done a good job of picking the for SSL, for TLS, the good cipher suites and things like that. It's the best answer I can give you.
So you talked a lot about the potential of malicious package updates. Is this actually an issue in practice so far, and are there any means to detect those more or less automatically?
Yeah, we have found modules that open reverse shells. Those particular modules are not in the registry anymore, and we found other modules with that were non-malicious but had like 400 meg of credit card data in them, things like that. So there is ways, specifically the malicious ones, there is ways to detect it. We're working on it through instrumentation. Through the standard practice of instrumentation and machine learning, we will have a solution. We're trying to solve it, but it's really, we can't scale with NPM, right? Like the best solution is to audit all the crap that you're using, which is a very, very tedious process. We're trying to expose the audit efforts that we've done through a verified module program, where we're very explicit that it doesn't mean that it's secure, but it means that a human looked at it and did at least a thorough audit, which is more confidence than just saying, well, this thing has no known vulnerabilities, and it's so.
But
yeah,
you're running against the clock on updates, right? Because it's automatic on a lot of sites.
Yep, it is an absolute nightmare to keep up with. It is impossibility to keep up with. So, on the one hand, looking, do any of your, to start out, we break it down from a subset, or break it down to a subset. We say, does any of your modules actually use startup scripts? There's a rather small percentage of modules in the registry that use startup scripts. So if we say we're going to audit all of them, well, and we just ignore anything that doesn't have startup scripts, or install scripts, that becomes a more obtainable process from a human. There's no current automated solution that I'm aware of.
And it doesn't end with startup scripts, right? So as soon as your module is loaded, you have pretty much all the stuff.
Yeah, right. You can hook require and do whatever you want, really. And that's the thought there. The most obvious is you're going to backdoor your module, backdoor your startup scripts, and that's the behavior. But yeah, you can just backdoor your module. Yep, and there's native modules, right? So you could have a native module that builds and introduces a small backdoor or something. A lot easier to hide. Again, you can hide it in obfuscated JavaScript, but it's a lot easier to hide it in C, right? Obfuscated C. So I think I think it's a real threat, right? Like if you have something that actually is security sensitive, and that you're not auditing that dependency tree, or having somebody audit that dependency tree, I do think that there's potential for abuse. But and we've seen it. It's been limited. I've probably seen 6 modules in the course of 6, 7 modules in the course of my experience with Node that have been actively malicious. There might be other ones out there, or backdoored ones. I'm specifically talking about ones that did something nefarious on startup or on install.
Thanks.
How do you said you found, or we found, or we see, how do you find stuff? Do you just like poke around the registry just randomly?
So if you could imagine a child in a sandbox, and then picture me in that sandbox instead, splashing around, that would be about what it looks like.
Okay.
And to be frank, that's pretty much what we do. So we started out, as an example, we found the MS vulnerability by taking all of the modules in the registry, parsing their AST, sending any regular expressions that we found through a library by Substack called SafeRegX. That gives you, it's not perfect, it's actually very false positive prone. And that one says, hey, this one might be vulnerable. And then we took those and put them in a list. And then from there we took those, and there's a Java tool out there that further tells you if it's able to be vulnerable. And we ran all of those through those, and then we split that out into a list and said, okay, it might be vulnerable. And then once we've confirmed that we have a vulnerable regular expression, like the MS one, we'll take that regular expression then, and we'll create a job queue across all of the modules and say, did we find this string anywhere else in the registry, and sort of just keep doing that, turn that over and over again, right? So we've got a rabbit job queue that we can push a button and audit all those modules or run jobs against. That's sort of my methodology. Is I start with a pattern, right? I look for childprocess.exec, and I look for an interesting pattern, and then I use wonderful tools like grep to say, okay, which ones use child process and which ones use exec, and point those out. And then I look at those and I say, okay, well, here's 600 things I need to look through. Which of these get input from the user, right? And that's an interesting problem because, is this module supposed to be used by a web server? Is it supposed to be used by some command line? Is it for CLI or something? And then you have to look at the common case, right? So what we tend to do is if we're going to report an advisory, we look at the common case and say, is this commonly used in this way? Yes. Okay, it's a vulnerable condition, create an advisory. Otherwise, we sort of just document that warning and move on. That's kind of my methodology anyway.
The Node Security Project advisories list,
Mm-hmm.
Is it available in a machine-readable format? Or is it just...
Yeah, if you hit api.nodesecurity.io/advisories, it'll dump out all that JSON. We basically our constraints on there is you want to use it internally and digest it, cool. If you want to build an open source tool on it, cool. You want to do something commercial, like we'd love to sort of partner on that. So we sort of like limit commercial use of it, just or license that data. We license that data to a number of other tooling vendors that want to integrate that data. Basically, so we can afford, we've got 7 people on the team. We have 3 full-time developers. And so we try to, keep the open source side of it. That information basically always trickles downhill. It always eventually gets into the community via the advisory list and a couple other information streams that we're working on making open.
I'd love an RSS feed that I can put in the Slack channel.
Yeah, we do have, so there is a notification feed. We could do RSS. There is a notification feed, Slack integration on the Node Security IO app. So you can do email or Slack. And what we're trying to do there, instead of just having like this fire hose of vulnerabilities, which it currently is, we're trying to have the notification options to say, tell me in Slack when there's an advisory that's out that affects one of my projects, right? Or that's above a certain severity level, or do some of those combinations to make it a little more interesting than just a fire hose. Right now, there's not a lot of feeds, so the fire hose isn't that bad. But yeah, that RSS feed is. It was there. It got killed when we retooled the project, and we just haven't put it back. So, yeah.
Do you have like elevated access into the NPM registry, or is everything you're able to do just through?
Yeah, we're normal people when it comes to we have one repository that we have one communication channel that we share with NPM because we are a vendor, and so we use that repository and that communication channel to collaborate. But anything and we do have, I guess, private access to code repos just to do pull request reviews for that private code. But other than that, like I don't have access to Fastly, right, the CDN, or I don't have access to production servers. That would be a horrible idea.
But you don't use it for good. Surely that would never be a problem.
Everyone has their price. I'm just kidding.
Yeah. Did you yeah, I don't know. Nobody else is asking anything. Oh, that's another question. I noticed a lot of
everybody to sleep. There's one thing that I didn't mention in the presentation that I wanted to mention in that sort of in your code section of the best thing that you can do to make my job suck is to have good input validation. We see this time and again with Express apps having vulnerability where happy apps don't, because happy apps have a good story for joy validation within the route handlers, and Express leaves that up to you to apply that validation. Again, just being strict about, okay, this is an integer, this is a string, it's an email address. It makes my job horrible. Yeah.
So I noticed that a lot of your examples used happy. Is that because and yet is like a happy shop, or just because what you're familiar with?
I like happy. I have no bias against. I mean, we do, and yet's a happy shop. We build stuff in happy. There's no question there. But I have no problem with Express. I have no problem with Restify. I think that they both serve their purpose. They all serve their purpose, right? They're different patterns that work well for different teams, right? So
yeah.
I like happy. I mean, happy has the security true option. You just turn that on, you're good, right? I interrupted somebody. Sorry.
Yeah, sort of a sideways question. Did I hear correctly that you also work on Lyft security?
Yep, I'm the founder of Lyft.
So, oh wow, cool. Okay.
Living the brand.
All right. So, any cross fertilization there? Any lessons flowing one way or the other? Like, oh, why don't you do it this way?
Yeah. So the Node Security team is made up of 3 developers from the Andyet team and 4 researchers from the Lyft team. So that's sort of the how that works. Our research, there's basically no boundary there other than we flow our advisories. As we do assessments for our clients at Lyft, we're auditing dependencies and things like that. Those end up flowing into the pipeline of advisories for the Node Security project, right? And then they trickle downhill, right? We don't just keep them in our back pocket for secret O days. Plus, most of them are not that exciting anyway. And other than that, we so as we audit things for NPM or any of the clients, so that's how that works. So
Are there any
Good question.
Are there any plans for like an NPM transparency list, something that actions on NPM get published to, so people can view them? And
I can't speak to that. That would be pretty cool. I think having that. I definitely think that'd be a fantastic feature, and you should totally bug CJ and Lori about that. But that's not. I mean, those are things that we talk about, and things that we can help influence internally, and that's definitely something that is on our sort of like rah. But we have to sort of pick and choose what we fight for as well, because they only have so many resources, right? So that would be fantastic. I don't know if we could actually do that externally. I mean, could we? We've got kind of a feed, but we don't see things like new contributor added. That might be in the JSON data, that's provided in the registry. We might be able to just kind of fire hose that and figure that out. But I think that would be better to come from within.
build it maybe like the certificate authorities are building the certificate transparency list. Something similar.
Yeah. Yeah, I mean, I could see something being, collaborative, but even then, like, we're not, technically they're paying us, we're not an independent entity at this point, right? So, like, if we, we're trying to be, but I could see them maybe do something with the foundation. I don't know. I think they could do a good enough job, providing that data. Any other thoughts, questions? I know I babble a lot. Like, it was all over the place. I apologize. It was good, but all over. Transitions were horrible. Any other questions? You can always find me on the internet. Yell at me on Twitter. Make sure to put the _ in there on Twitter. Otherwise, you're going to yell at the actor, and it's really fun when people do that. I think he actually quit Twitter, but yeah. Anyway.
Any more questions? No. All right. Well, thank you very much, Adam. Appreciate it.
Awesome. Well, have a good evening, everyone. Thanks for the invite. I appreciate it. See ya.
Thanks. See ya. Just hit stop.